Hey, welcome back to Ramsey Land. Today I want to share with you my new radiometer lamp. Check this out. So all I'm using in this investigation is some warm water, a tray. This is a light meter. I'm using a tachometer for RPMs. This is my Crooks radiometer lamp. And here's just an ordinary Crooks radiometer. And I'm also using an electronics duster too. What I like about my Crooks radiometer lamp is that it's on a dimmer switch. So right now you can see that the black and white veins aren't moving at all, but if I just turn it on low so the incandescent lights just barely light up, you'll see that those veins immediately start spinning. So with the door open on the lowest setting, I can see that this is creating just around 200 lumens, maybe 200, looks like 216 lumens. With my laser tachometer, let's see how many rotations per minute that's creating. About 1,065 rotations per minute. Let's find out what it does on the highest setting. Okay, so now we're gonna pull up the dimmer switch to full strength, and let's see how many lumens that creates on our, definitely over 1,000 lumens now. Looks like it's maybe up to 1,300. Okay, with over 1,300 lumens, let's look at our laser tachometer and see how many rotations per minute we're getting. And it looks like, whoa, 2,844 rotations per minute. Definitely a relationship between the intensity of the incandescent light and the rotations per minute. So people often make the mistake of thinking that it's light alone that causes the veins to move. So you can see right now that the radiometer isn't spinning. Over here I just have warm water. Watch what happens when I pour warm water on the radiometer. The veins start to spin. Well, I didn't add any extra light to it, so why would warm water cause them to start spinning? I didn't increase light. All I did was pour warm water on the radiometer. It immediately starts to spin. Maybe this is more of a heat motor than a light motor. Think about what's really happening inside the radiometer. What's really making those veins spin? So again, notice that when I pour warm water on it, the veins are moving clockwise. They're moving in this direction, okay? Now I'm gonna spray a little bit of cold compressed air onto the radiometer. Watch what happens to the rotation of the veins. Watch what happens to the direction of the rotation. Now they're moving counterclockwise. Why would they move in this direction after moving clockwise when I poured the warm water on it? They've reversed their rotation. Why are they doing that? Think about what's really going on in the radiometer. So the chemist Sir William Crookes invented his Crookes radiometer in 1873. And at first he thought it was just photons causing it to spin. But over the next 10 years that caused a lot of debate. If you look closely at the Crookes radiometer, it's under reduced pressure. It's in a vacuum. This pressure has been reduced down to about 1 Pascal. If there was no gas at all in the radiometer, the veins wouldn't spin. If there's too much gas inside the radiometer, it would create drag and it would make it difficult for the veins to spin. But about at 1 Pascal, they've determined that it's just perfect for its rotation. But what's really causing it to spin if it's not just photons? What's hitting those black veins causing it to turn in one direction, or when it's cold, causes it to turn in the opposite direction? One of the first things you want to notice about your Crookes radiometer is half the veins are black and half of them are white. So when electromagnetic radiation hits the surface of those black veins, it actually increases the temperature, and that warms the air molecules around the black vein. Less electromagnetic radiation is absorbed by the white veins, and so the gas around the white veins is actually cooler than the gas molecules around the black veins. So this temperature gradient in front of the black vein versus the white vein creates what we call thermal transpiration, where the gas tends to move a little bit quicker around the edge of that black vein than it does around the white vein, because there's actually a little bit more pressure around the black vein than the white vein. And this is what causes it to turn clockwise. Now you might say, well, what about hot water? There wasn't any light that caused it to turn when you poured hot water on it. Why did it turn then? Well, the water heats up the glass, and that creates infrared radiation that's just right above 760 nanometers. So I can't see that radiation. It's beyond the light spectrum that I'm able to see with my eye. But that infrared radiation, again, heats up the gas molecules around the black vein more than the white vein. And through thermal transpiration, the pressure gradient between the white and the black inside causes it to spin. Now, when I started to shoot the little cold condensed can of air against it and it turned counterclockwise, that's because the black vein doesn't just absorb radiation, but it also emits radiation. So as I cooled the air inside, the black vein was emitting radiation, causing it to spin in the opposite direction. So this is more of a heat motor than it is a light motor, because you're really heating up the gas around that black vein more than the white vein. And through thermal transpiration, that gas pressure gradient between the black and the white vein causes it to spin. That's what's really going on in our Crookes radiometer. I hope you enjoyed today's edition of Ramseyland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.